Welcome to the deep dive. Have you ever tried to get your smart home assistant to do something genuinely complex, like help you cook a meal from scratch, actually adapting to what's in your fridge?
Or maybe navigate a new city, not just
Yeah.
using a map, but like really getting the landmarks and maybe sudden changes, like a street closure.
Yeah, if you have, you probably run into that wall where current AI it falls flat when it needs to connect the huge digital world with our messy physical reality.
Hmm.
So today we're diving into some really interesting research that's trying to break down that boundary. Our sources introduced this new idea, a new paradigm for AI agents they call embodied web agents.
It's a really fascinating concept. Our mission today, for you listening, is to unpack the big challenges and also the opportunities in building AI that can just fluidly move between browsing the web and, actually doing things in the real world, a bit like how we do it all the time.
Right.
We'll explore how this integrated approach isn't just like a small step up, but potentially a whole new direction for AI intelligence.
Okay, so let's start with the core problem this research is tackling. Right now, most AI agents kind of live in separate boxes, don't they?
You really do.
You've got your web agents, brilliant at finding information online, reasoning over tons of data.
Yep, the digital specialists.
And then you have these other systems, the embodied ones, that are good at sensing the physical world, planning movements, taking actions. Robots, basically.
But they're separate. That's the key. One or the other.
And that separation, as the research points out, really holds AI back from tasks that need both kinds of smarts.
It really does. I mean, think about cooking. An AI can pull up a million recipes online, sure.
Okay.
But if it can't physically see the potatoes in your kitchen or, pick up a knife or tell if something is actually cooked, it's pretty useless for the task, right?
You can't bridge that gap.
Or navigation. A system might have the latest map data, all dynamic updates. But if it can't look at a building and understand, that's the landmark the map mentioned, or see that, there's a big street fair blocking the way,
Yeah.
it's missing vital real-world context.
Even something like figuring out a building's style.
Right. You need to look at it. That's perception.
Yeah.
Maybe check Wikipedia. That's the web knowledge to really understand its history or significance. The physical and digital info, they have to work together.
So it's not just about, duct taping two systems together.
Not at all.
The research is saying the challenges run much deeper, they're intertwined. It needs a kind of unified intelligence.
That's the goal, that unified intelligence.
Okay, so if AI is stuck in these silos, what's the big idea behind embodied web agents? How do they propose bridging this divide?
Well, the core concept is, what if those web agents could actually perceive and act in a 3D physical world? And what if the robots, the physical systems, could just naturally tap into all that knowledge on the web whenever they needed it?
Kind of like us.
That's the analogy they use.
Yeah.
As humans, we don't really have a separate physical brain and digital brain.
Right. I don't consciously switch modes when I look at my phone for directions, then look up at the street sign.
You just do it. You glance at your phone, see the map, look up, spot the cafe it mentioned, maybe quickly check its online reviews.
Yeah.
It's fluid, seamless.
Okay.
The goal is to get AI agents to achieve that same kind of integrated intelligence, the best of both worlds.
And the examples they give really make it concrete. You mentioned cooking.
Yeah. Imagine an agent that first looks in your physical kitchen, sees what you have,
Okay.
then it searches online for recipes that match those ingredients. Maybe it finds one, but you're out of butter. So it flips over to a web shopping site, orders the butter, gets confirmation, and then integrates that back into its plan to actually start cooking the dish in the physical kitchen.
Wow, that's a whole sequence across both worlds.
Or think about tourism. An agent is like walking through a city using its sensors.
Mm-hmm.
It sees an interesting building, uses its perception to analyze the architecture, then maybe pulls up Wikipedia on the fly to learn about its history.
And then?
And then maybe it even takes some photos with its virtual camera and posts a review about the landmark on a website. It's this constant back and forth between doing things physically and accessing information digitally.
Okay, so to actually test this, they couldn't just use existing tools. They had to build a whole new environment, right? This embodied web agents task environment.
That's right. They needed a unified simulation platform where these agents could actually operate across both domains.
What does that look like? What are the pieces?
It's pretty clever. It has three main parts. First, there's the outdoor part. This uses real-world visual data from Google Street View and Google Earth.
So not just a clean 3D model, but actual messy street photos.
Yeah, from cities like New York, Boston, Philly, Pittsburgh. It gives the agent that noisy real-world visual input, which is crucial. They build a navigation graph from this data.
Okay, that makes sense for realism. What about indoors?
For indoor scenes, they use AI 2-R. That's a well-known platform for photorealistic 3D indoor simulations.
Yeah.
It features interactive kitchens where agents can actually pick things up, slice them, turn on stoves, and the system tracks the state of objects, like is sliced or is cooked.
So it can simulate the cooking tasks.
It can. And finally, there's the web component. This isn't just letting the AI browse the whole internet. They built 5 specific functional websites:
Like,
a homepage, a recipe site, shopping, OpenStreetMap for maps, and Wikipedia. They're built to be interactive, so the agent can click buttons, type in search boxes, navigate pages, just like we would.
so they built this integrated world, and then they created the tasks, the Embodied Web Agents Benchmark.
All right. And it's not just a few simple tests. It's got about 1,500 tasks across 5 different areas.
1,500?
Yeah. And the key thing is all of them require the agent to coordinate between the physical simulation and the web simulation. That's what they're really trying to measure, that cross-domain skill.
So what kinds of areas do these tasks cover? You mentioned cooking and tourism.
Right. So the 5 domains are cooking, which is matching physical ingredients to online recipes, maybe buying stuff online first. Then navigation, using online maps, but also dealing with what you physically see. Shopping, which could involve checking something in the store versus online prices. Tourism, like we discussed, linking landmarks to web info. And a really interesting one, geolocation.
Geolocation, how does that work?
Basically, the agent has to figure out where it is by exploring the simulated physical environment and using online resources, maybe searching landmarks it sees, almost like being dropped somewhere unknown.
Wow, and some of the specific task descriptions sound incredibly complex.
They really highlight the integration needed. Like one task is, take a walk in Manhattan from MoMA to Rockefeller Center, explore a Gothic building, research it, take photos, and post reviews on Reddit.
That's a lot of steps across different domains: physical navigation, visual recognition, web search, image capture, web interaction.
Or the cooking one. Cook apple bread with fried egg and potato, buying butter online if needed. Again, you see the loop.
Sure.
Check physical inventory, check online recipe, check need, go online to buy, return to physical cooking.
And that really challenging one, you are kidnapped. Try to walk around and guess where you're using an old phone without GPS.
Yeah, that forces the agent to rely purely on observation and web searching based on what it sees. It really shows these aren't just simple combined tasks. They involve some really deep intertwined challenges.
Let's talk about those challenges. One big one they flag is the perceptual grounding problem. What exactly is that?
Perceptual grounding is, it's about connecting abstract language or instructions from the digital world, like a recipe saying, cook until golden brown, to the actual sensory input from the physical world.
How does an AI know what golden brown looks like?
Right. For us, it's intuitive. But for an AI, that instruction needs to be linked to the patterns of pixels changing over time in its camera feed. It's not a simple label. It involves understanding color, texture, context, maybe even how light is hitting the object. It needs embodied perception, actively looking, maybe moving, to understand the physical state.
It's not just recognizing a static image.
Not at all. And then there's the challenge of cross-domain planning.
Which sounds like deciding when to use which world. Physical action versus web search.
Sort of. It's about making smart decisions on how to sequence actions across domains, especially when information from one might change what you should do in the other.
Okay, give me an example.
So the online map might show a clear path, but then the agent, through its physical eyes, sees a big protest blocking that path.
Ah, reality interferes with the digital plan.
Yes. The agent needs to recognize this conflict and dynamically replan. Maybe it needs to quickly search the web for alternative routes while navigating away from the blocked street physically. It requires this constant awareness and integration of both contexts, not just switching, but blending.
Okay, so given these really tough challenges, how did current AI actually do? They tested some big names, right? GPT-4o, Gemini.
They did. They used several state-of-the-art large language model-based agents. And the main finding was, well, that current systems are, and I quote the paper here, far from satisfactory compared to what humans can do on these tasks.
How far? Is the gap big?
It's pretty significant. Just to give you a number, for those complex navigation tasks, GPT-4o achieved an overall accuracy of about 34.7%.
Okay, and humans?
Humans performing the same tasks in the simulation got over 90% accuracy. 90.28% to be specific.
Wow, okay. That's
Yeah.
yeah, that's a huge difference. 34 versus 90.
It really highlights the difficulty. And what's super interesting is why they struggled. The analysis showed it wasn't usually because they failed at just web tasks or just physical tasks in isolation.
It was the
It
connection.
was the cross-domain integration. That's where they fell down most often. Interestingly, they tended to do better on web-only parts of tasks than the embodied-only parts.
So they're still maybe more comfortable in the digital realm. How did these integration failures actually look?
It led to some strange behaviors.
Yeah.
Sometimes agents would just get, well, stuck, like trapped in the physical simulation. Maybe just repeating the same pointless action like bumping into a wall without realizing they needed to go check the online map or recipe for the next step.
Or the opposite, stuck online.
Yeah, or endlessly clicking next on a recipe website page after page, but never actually starting the cooking actions in the kitchen simulation.
Just browsing forever.
Pretty much. Or they might switch back and forth between the web browser and the physical view without actually doing anything meaningful in either.
Yep.
Just switching contexts randomly.
And you also get things like mixing up instructions.
That happened too. Instruction action misalignments. The example given was slicing lettuce when the recipe clearly said, slice the apple. It shows a failure to ground the language instruction in the correct physical action or object.
Oh, okay, that lettuce apple thing really paints a picture. You can see how disconnected things are.
It does make it very clear.
Hmm.
But there was a bright spot, an exception that actually shows the potential here.
Oh, yeah.
In those geolocation tasks, the ones where the agent has to figure out where it is, an embodied web agent that could actively move around the environment and also access the web to look things up. It performed significantly better than simpler approaches that just looked at static images without exploration or web access.
So when the integration did work, even partially, it offered a real advantage.
It strongly suggests that yes, it shows that combining active physical exploration with online information gathering could be really powerful for certain tasks.
So let's bring this back to the listener. What's the big takeaway here from this deep dive into embodied web agents?
I think what this research really drives home is it's not just about how far AI still has to go. It's also about the kind of intelligence we should be aiming for.
Meaning,
Maybe true, general-purpose AI won't just come from making current models bigger or feeding them more data. It might require a fundamental rethink about how AI connects perception and action across all the different parts of our experience, the digital and the physical.
it's a shift in the approach itself.
It feels like it.
Yeah.
And understanding this is important because it really points towards the next frontier, moving beyond AI that's good at just one thing, towards systems that can handle the messy mix of online and physical reality that, we navigate every day without even thinking about it.
So this idea, this paradigm of embodied web agents, even with the current challenges, it really represents a significant conceptual step towards AI that can genuinely interact with the world more like we do. The potential there seems huge, even if we're not there yet.
Definitely. And it leaves us with a really interesting question to ponder. If today's AI struggles so much right at that seam, at the intersection between the digital and physical, what kinds of truly new intelligence might emerge when AI can finally integrate these worlds seamlessly? What becomes possible then?